scatter graphs or scatter diagrams. So scatter graphs look as they sound. We've just got the dots scattered across it. We don't do a dot to dot thing with them. Okay, so generally speaking, there's a couple of traditional types of questions that come with this, and the first one is to do with finding what's known as the correlation. Okay, now before I do that, this one additionally asks us to plot one more piece of information on here. This is to do with the cost of a car compared with its age. So we've got a 4-year-old car that's worth 5,000. So I go to 4 and up to 5,000, and I'm going to put just a little dot there, so to add that in. So we're talking about this correlation idea. So the correlation is a fancy word, if you like, for relationship between. In this case, we can see there is a bit of a pattern to these dots. They're all generally going in this direction. And when they point in this direction, this is called a negative correlation. And the reason for that is a negative correlation doesn't mean that it's bad, but what it means is that as the age goes up, the value comes down. So as one of the variables goes up, the other one goes down in the other direction, and vice versa. So the younger it is, or the more value it has, the younger it is. And conversely, if the older it is, the less value it has. Okay, so it's negative because the two variables are going in different directions, if you like. One increases, the other decreases. The next thing it's asking us to do, it says the next car that arrives is a 6-year-old car, and we've got to estimate the value of the car. Now this has 2 marks, and they're not telling you something, but they're expecting you to do something. So in order to get your 2 marks, you must draw what's called the line of best fit. So the line of best fit, as it sounds, is going to try and sort of draw and show that pattern that we just saw. So what you're trying to achieve with your line is to get it to go roughly through the middle, so that once you've finished drawing your lines, there should be roughly the same dots or crosses on both sides, so it looks nice and even. So I'd say that was more or less here. So I've got 1, 2, 3, 4 dots this side, 1, 2, 3, 4, and a couple that are more or less right on there. So now we've got the line that actually helps us do the estimating as well. So we want a 6-year-old car. So here's 6. So I go up to the line, and it is quite well worth doing it with a ruler and dotting these lines on. It makes it easier to read. So then if we go across from there, we can see that it's almost 4,000 here. Now there are 5 little squares here for every 1,000, so that means it's going up in 200s. 1,000 divided by 5 is 200. So it's actually 1 square down here. So it's not 4,000, but it's 3,800. Okay, let's have a look at some more examples so we can talk about the other sort of things we get with correlation. So this time this is to do with test scores and the amount of time that you spend revising. So we can see that this time the pattern is going in this direction, which is known as the positive direction. Okay, now actually there are a few more that we're supposed to have put on, so let me just put these extra points on as well. So when 7 hours is 70 marks, 5 hours 60, and 8 hours 86, which is going to be there. Okay, so this time it's going in this direction, so it's positive. So what we mean by that is that as this increases, so does this. So the greater the time spent on revising, the higher the score you get in a test. Hopefully you're aware of that fact already. Okay, so but the idea of a positive correlation being shown in this thing is the fact that as this increases, so does this. Okay, it then tells us this time to draw the line of best fit on our diagram. So again, just trying to get as close we can through the middle of all the points and draw it right the way across your graph there. So again, maybe I should have been a little bit lower down. It's a bit difficult to judge with the thick pen again. Okay, now we've got our line of best fit on here. It asks us if a student has spent 4.5 hours revising, what would we expect her score to be? Okay, so 4.5 is here. So if we go up to the line and then across from the line over here. Okay, do it with a ruler when you're doing it. I just don't want to get the ruler in the way. So that's just under the 60. Again, if we look at the bottom here, it goes from 0 to 10 with 5 squares. 10 divided by 5 is 2, so each square is worth 2. So that would actually be a score of 60 minus 2, which would be 58%. Okay, now, so far we've seen negative and positive. There is a third one, and that's when they have no pattern whatsoever. So they're all just randomly dotted everywhere. And then we just say that there is no correlation. There is no relationship between the two things. So one last example. This one is about the height of some students and how wide their arms are, where they stretch them out, their arm span. Okay, so first of all we're asked to look at what type of correlation. So the dots are all, the crosses are all going in this direction, so that means we've got a positive, I'm just going to do it like that this time, positive relationship, a positive correlation. Then it asks us to find out how wide we expect the arm span to be of a student that is 150 centimeters high. Okay, so we're estimating this. Do not be fooled. It hasn't told you to do it, but there are 2 marks for this question, and one of those marks is for drawing in the line of best fit. So pretty much any time you get a scatter diagram, if they haven't already drawn one, you draw a line of best fit. Okay, so I think that's more or less going through the middle of those there. So we want 150. Here's 150. So we go up to the line and then across here. So it's just under the 150. Now again, we've got 100 to 110 is a difference of 10, and we've got 5 spaces, so 10 divided by 5 gives us 2, so we're going up in 2s. So if we take 2 off 150, we get 148 centimeters as the arm span.